Hello, committee. Thank you for this opportunity. I want to first preface my presentation with the critical thinking model that I use. I'm going to use it throughout this presentation, briefly here and there. But I'm going to assume that since I don't know much about the program, certainly I don't know much about one in a detention center, I don't know what the curriculum allows me to do, but I'm going to assume I can use this model when I teach. If I can't, that's no big problem either. But I always remind my students of the definition of critical thinking whenever we start any type of concept or lesson. So let me get started here. Since critical thinking is the art of analyzing and evaluating our thinking with a view to improving it, we start off by thinking of the elements of our thinking, and the students would already have known this, and they would know that the circle here, notice all these parts of our thinking blend to create that white light, that light bulb going off, that aha moment. So first we'll start by considering the concept of percent, so we can review for a minute. We've already been over this, but percent literally means out of 100 or for every 100. The word cent in the English language used to mean 100 instead of, say, a penny as we use today. So percent, when we think of it in terms of what it means as a concept, it's per every 100. For example, Shaquille O'Neal shot 53% from the free throw line his entire professional career. That means he made 53 free throws out of every 100 attempts, or hit 53 free throws for every 100 attempts he made, which is not very good, by the way. So we're going to think about when we take a percent and we increase it or decrease it, how we can find that percentage of increase or decrease, which again is another concept which starts with a simple plus and a minus, because we can infer or conclude that if a percentage increases, we're going to end up with a positive answer. If it decreases, we're going to end up with a negative answer. So let's take a moment and consider this concept in regards to the number line. This idea of positive and negative. Obviously, if we increase, we are going up the number line, which is a positive action. If we decrease, we are going down the number line, which is a negative answer. That's just the basic fact, and we need to remember that when we are doing percentage increase and decrease. Now, let me ask you, let's think of point of view here, frames of reference. Who might use percentage increase and decrease? Deshaun. Good, yes, a basketball coach. You might want to find out why someone has shot a certain number of free throws one month versus another month. and think of the percentage, whether it increased or decreased, and what they might mean for that player or the officiating in the league. But let's consider that could be either an increase or a decrease for that shooter. Also, what's another frame of reference that someone might be looking at percentage increase and decrease from? Jimmy, yes. Weatherman, or we might say meteorologist, since we don't know if that's a man or a woman. But a weatherman might, or I'm sorry, a meteorologist might want to look at changes in degrees. Actually, I'll take that a step further. I'll take make it more topical. I'll think in terms of a climate scientist, someone who studies climate change. Because if the temperature, if we're thinking in terms of temperature as a climate scientist would be, they might want to look at why an average temperature in Fairbanks, Alaska went from 10 degrees to 22 degrees, which clearly goes up from 10 to 22, which is an increase on the number line. Or they may look at a decrease. If we went from 50 down to 34, that would be a decrease. So in the most basic sense, let's interpret this. Let's draw a conclusion here. If we increase from 10 to 22, we should end up with a positive answer. And by the same token, if we decrease, say from 50 to 34, we should end up with a negative answer. That's just a basic fact, correct? Now, before we solve these, I want to remind you that the whole concept of the elements of thought begins with asking questions. So if you ever get confused or something doesn't make sense, feel free to interrupt me. Stop me at any time. So let's shift here and look at percentage increase first. If I said find the change in percentage of 10 to 22, the first thing we'd have to do is find the difference. And we do that by subtracting the new number minus the old number in our first step. And we do that, we should end up with 12. Correct? All right, so our next step is we divide this number. My marker would work. By 10, the original number. As a concept, that's important because that's what we're changing from. So if we divide 12 by 10, that should be a 2 there. There we go. 10 will go into 12 how many times? 1, good. That would make it 10. We subtract 10 from 12, that leaves us with 2. So we make a 0, bring that down, 10 goes into 22 times, and we're done. So What we do next, our third step, is we take that number, which is 1.2, and we multiply it by that original concept of cent or percent, which is 100. And that means we take the decimal point, since this is the tens place, this is the hundreds place, we move it to the tens and the hundreds, which would mean we'd have 12, I'm sorry, we would have 120%. Oops, not dollars, excuse me. 120%. So the percent increase here is 120%. Any questions about that? All right, good. So let's say we start from a number and we decrease, say 50 to 34. And we want to know the percent change. Again, conceptually, we should see, since we are decreasing, we're going to end up with a negative answer. So, first of all, remember we have to find the difference by subtracting the old number from the new number, which is 34 minus 50, which should leave us, since our larger number is negative, we find the difference here, subtracting 34 from 50, we should get 16. You should already know how to do this. Any questions about that step there? All right. So that's our first step, remember. Now, our second step is we divide this difference of negative 16 by 50, because that is our original number, which is negative 16 divided by 50. So 50 goes into 16 how many times? 0. So we add another 0 here to make that 160 for this spot. 50 goes into 16 how many times? Or I'm sorry, 50 goes into 160 how many times? 3 times, correct, because 3 times 50 is 150. So that leaves us, we've got to bring our negative sign down with us. That leaves us negative 10. 50 won't divide into that, so we have to have another 0 here. Add that 0 to make that 100. 50 goes into 100 how many times? 2, correct. Good. So 2 times 50 is 100. And remember, that leaves us with a negative answer. We're not done yet though, because we have to take negative 0.32 and multiply it by 100, our third step. So, in doing so, Again, we should know from previous lessons that when we are multiplying decimals and we're doing so by 10 or 100 or 1,000, we simply move the decimal point over by the numbers to the right by the amount of zeros that are there. Since there's 2 there, that makes this negative 32%. That's how we come up with the percent per 100. So we would have, remember we started off, we knew we would have a negative answer, and negative 32% is the percentage change from 50 to 34. Now, that might seem convoluted and complex, but there's a rather simple formula that you can use, and you can use that here in a minute because I have some handouts for us, and we're going to go over this whole concept of percentage increase and decrease with the purpose of coming up with the correct answer. So what we do is we take the amount of change which is we get that by taking the new number, subtracting the old number from it, and dividing that by the old number. And then multiplying that times 100 to get our change of percent. Now remember too that in either answer that we get, we can write that 120% is as a positive change. Without that, some instructors might find that is incorrect without the positive side. So our percent change is a positive 120% change, or you could write it as it is a 120% increase. So for our other answer, we could write it as a, let's see, as a 32% decrease, or a negative 32%. Any questions or concerns? All right, I'll hand out the problems I want you to work on. And remember, I want you to ask questions. Don't worry about getting confused. If you do, let me know. I get confused all the time. That's part of being a good critical thinker, is knowing that we all have limits to our thinking. And so there's limits to mine for sure, but that's how we continue to learn, by acknowledging that. So when you get stuck, or you have an issue, please stop me and let me know, all right? Okay, that looks like we are done.